QSO Today, episode 444, Adam Farson VA7OJ / AB4OJ. Welcome to the QSO Today podcast. I'm Eric Guth, amateur call sign 4Z1UG, where I demonstrate the diversity and relevance of the amateur radio hobby and its impact on society by interviewing ham radio operators, many of whom played vital roles in shaping our technology through the amateur radio hobby. And while many people might say, ham radio, do people still do that? This podcast demonstrates through in-depth interviews just how amazing, diverse, and dynamic the amateur radio hobby continues to be. The QSO Today Virtual Ham Expo was a success last weekend and is now in the 30-day on-demand mode. All of the presentations, along with their Q&A, are there to be viewed. We have even closed captioning for the hearing impaired. Click on the banner in this week's show notes page to get back to the Expo entrance. You can still buy a ticket for the Expo on demand. While I had planned to bring you a new episode this week, my guest suddenly rescheduled our interview into May. I am left reprising an earlier episode that I know that you will enjoy. Adam Farson, VA7OJ and AB4OJ, began his ham radio journey over 60 years ago as a youngster inspired by electronics and eventually ham radio in his native South Africa. Pursuing a career in the broad science that surrounds telephony worldwide, Adam has adapted telephony methods and test equipment to evaluate amateur radio transceiver performance. Adam shares his ham radio and professional journey in this QSO Today. VA7OJ, this is Eric, 4Z1UG. Are you there, Adam?
Yes, Eric, 4Z1UG, this is VA7OJ. Good morning, Eric.
Good morning, Adam. Thanks for joining me on the QSO Today podcast. Can we start at the beginning of your ham radio story? When and how did it start for you?
Well, it started in 1948. I was 8 years old, and my father bought me a Fillmore crystal set as a birthday present. It was in kit form. He helped me assemble it, and we strung 15 meters of wire out from the balcony of the apartment where we lived. This was in Johannesburg, and tied it to a convenient tree. And the set worked the first time, and we were able to hear all three local broadcasting stations. If you didn't adjust the radio properly, you could hear them all simultaneously.
How did that feel?
Well, gosh, I was hooked. I said, my goodness me, we've actually built a radio that works. And from that moment on, I was hooked. And I became intensely interested in all things electrical and radio. My parents were very cooperative, indulgent, I would say, almost. They bought me a number of books on the subject. A couple of books that remain in my memory are The Wonder Book of Electricity, a British book which explains the inner workings of electrical and electronic devices and systems, from the London Underground to an electric toaster and a radio and the electric gramophone or phonograph. Another book they bought me was The Boy Electrician, which was actually a book for the young constructor that even gave you information on how to build a lead-acid battery.
Do you remember the author of that book? Was that Alfred Morgan?
I think so. I think it was Alfred Morgan.
He wrote a series of great books for kids.
Yes, I think that book was by Alfred Morgan. It was a hardcover, a medium-sized book, and I cherished it. I don't have it anymore. I think I gave it away to another kid when I was old enough to feel I could let it go. I gave it away to another kid who was interested in electricity and radio, and I'd certainly benefited from it.
So how did it proceed from there?
Well, I developed an appetite for building things. At the age of 10, I built a tube tester. I had to wind a transformer for it with all the multiple filament windings to accommodate the different tube heater voltages. But the tube tester was built up in a small wooden box, and it actually worked quite well. It was a plate current and transconductance tube tester, and it worked remarkably well considering that it was crude. I kept that for a number of years. I actually used it to test tubes with which I built small receivers. This was another thing I used to do, I got into, was building receivers. I didn't build a superhet until much later in life. All the receivers I built were medium-wave TRFs. and they were capable of picking up the local South African Broadcasting Station, South African Broadcasting Corporation transmitters.
What's a TRF?
TRF is a tuned radio frequency. That is a receiver in which an RF amplifier delivers the RF signal to a detector or demodulator, which converts it to audio. The TRF has the disadvantage that it really has no selectivity, because you can't build an RF amplifier with a bandwidth of, say, 10 kilohertz to separate an AM signal from adjacent AM signals. So this is why the superhet came about, because it was much easier to put selectivity into a fixed intermediate frequency than it would ever be to put it into an RF amplifier that has to cover a wide tuning range.
So all the stuff you were building then was tube-type or valve-type radios?
Yes, it was all valve-type or tube-type. I didn't actually start using transistors until, now I have to think back a little. Transistors were initially extremely expensive, and it was only at university that we did some transistor experiments in the electrical engineering lab. But I would say in the early 60s I acquired a few audio transistors and started building simple audio circuits. RF transistors were just simply unaffordable to a high school or university student at the time. Tubes were plentiful because very wisely South Africa, like other Commonwealth countries, had encouraged its Crown Assets Agency to dispose of military surplus radio equipment to hams and other hobbyists.
So there was a large supply of military surplus.
Yes, there was a very large supply of military surplus, and it was quite inexpensive. My first amateur radio station, in fact, cost me probably the equivalent of about $50. It consisted entirely of military surplus.
When did you get your first license?
I got my first license in 1962. And what stimulated it was the acquisition of a working military surplus transceiver. In South Africa, it was illegal to possess radio transmitting equipment unless you had a license. And the one thing you didn't want to do was get on the wrong side of the law with radio equipment because of the political climate there at the time. So one day when we were driving back from my parents' home in what used to be southern Rhodesia, is now Zimbabwe, we stopped overnight in Pretoria, the capital of South Africa. This was a 3,000-kilometer drive. It took several days. And whilst we were in Pretoria, we went to see a surplus dealer who was a friend of my father's from the time when our family lived in Pretoria. We lived in Pretoria from 1950 to 1953. And he recognized me and he said, I've got something for you that I think you'll like. And he brought out a British Army number 62 set, which is documented on my website. It's a descendant of the famous World War II 19 set, although it was a better, more modern design. Well, he offered me this 62 set for £2, $5.50, and it was in working order. I couldn't resist it, so I bought it, hooked it up to the car battery, and found that it worked. And it was self-contained. It even had a 12-volt power supply inside the case. So now I had a transceiver, but I didn't have a license to go with it. So I sat down and found out what I had to do to get a license. I first had to learn Morse code. So I signed up with the Morse code class at the local technical college, which was offering code and theory classes for the PMG certificate, otherwise known as the radio telegraph license for marine radio operators. So I took the code class. In order to get a ham license, you had to, in South Africa at the time, you had to send and receive 12 words a minute, receive by ear and send by hand on a straight key. So thanks to the code class and to the fact that one of the students there loaned me an instructograph, which is a paper tape Morse machine, I was ready for the test when I went to take it in August. I'd also been listening regularly to the shore stations, which were broadcasting news, weather, and traffic at about 15 to 18 words a minute on various HF frequencies. and on 500 kilohertz. So I went in and took the tests and passed it on the first try. And I got the call sign ZS1ZG. This was in November of 1962. So that was when I was first licensed. Almost immediately, I tried putting the 62 set on the air, but it was low power, and I didn't really have any success at all, or on 80 or 40 meters with a long wire antenna. It only put out a couple of watts. And I didn't have a proper power supply for it. I was using a car battery, and eventually I ran the battery down. And the next thing I did was, at the behest of a friend of mine, I built a 20-meter transmitter out of an old World War II ARC-V transmitter. ARC-V was the designation for a family of radio equipment used by the U.S. forces during World War II and even for some time afterwards. It had modular transmitters and receivers for different bands, and typically they were mounted in a rack. And the thing about the ARC-V equipment was that the components used were of the highest quality, and you didn't want to use it in the transmitters in their original form because they consisted of a VFO driving a PA without a buffer, which meant that they suffered from chirp and incidental FM and other issues like that. In fact, the South African radio regulations prohibited the use of that type of transmitter because it didn't meet the spectral purity requirements. So I got an ARC-V transmitter, converted it to crystal control, and got it running on 20 meters. I had to modify it extensively. And that was my first transmitter that was viable in any sense. And my first contact with it was ZS2MI, the South African weather station in Marion Island. And that was really exciting. I had the QSL card for it, which I treasured, but unfortunately when I left South Africa, a container of my personal stuff went astray, and in that container were all my QSL cards, among other things. So anyway, I remember that as my first contact. And I worked quite a lot of DX, and I also got to know a number of hams in Johannesburg, 1,600 kilometers away, and we became fast friends because we used to rag chew for hours on end on 20 meters CW, and we really got to know each other quite well. There was one guy in particular who was an avionics technician who he was a few years older than I was, and he invited me to come and visit him when I went up to Johannesburg to visit my parents. By then, we'd left Rhodesia, and my father had got transferred back to South Africa, so we were living in Johannesburg. So I went to visit my friend, and I noticed that he'd built his own station out of Marconi equipment surplused from the South African Airways. So it was really beautifully done. He had a transmitter which was an aircraft transmitter that had been extensively modified, and an aircraft receiver, and various power supplies that he had to build because that equipment was designed to run off 28 volts DC. So he had to build mains power supplies for it. And they were a lovely family too. His wife was very charming, and they had a little daughter. And I made various other friends in the ham community in Johannesburg through these CW contacts. And this resulted in my getting quite involved with the local branch of the South African Radio League once I graduated and moved up to the north of the country again. Now, I would definitely say that ham radio influenced my career choice. I had always, ever since I can remember, I'd always wanted to be an electrical engineer. I mean, there was no argument about that. But once I'd got a taste of radio communications through ham radio, I said, I really want to get into the RF engineering field. So when I was in my final year, my senior year at university, my dad sent me an advertisement from the local paper, the Johannesburg paper, seeking engineers to work at Racal in Pretoria. Racal was the famous British radio communications manufacturer. So I applied for a job with them, and they invited me in for an interview. I went to interview with them in January 1964. which was the month after I got my degree. And they immediately made me an offer. And I remember my first day at work, the first piece of paper I had to sign when I joined up was the Official Secrets Act, because they were doing military work. And I spent 3 years with them. I learned a tremendous amount from working with Racal. In fact, part of the aspect of it that was most exciting of all was that we were doing some leading-edge work. One of our projects was a military manpack, a VHF manpack, and I'd say even more exciting than that was the fact that we were among the very first manufacturers to develop solid-state HF transceivers. I worked on power amplifiers for 2 transceivers, a 25-watt PEP manpack capable of operating up to 8 megahertz, and a 100-watt mobile designed to cover 2 to 16 megahertz. And this convinced me that the amateur transceiver with a pair of 6146s in the final was on its way out. Of course, when I said that at club meetings, nobody wanted to believe me, but events proved me right before too long.
Well, I noticed on your website, which is AB4OJ.com, which is your American call sign, that you have this amazing list of military surplus radios. And as you said, it sounds to me like your interest in military surplus radios began at the very beginning of your ham radio story. You've done an amazing job of preserving these pictures and stuff. Did you rebuild all the radios that are in that list? And are you still into military surplus radios?
I'm not really into military surplus anymore. I think what's happened is that interest has been transferred into refurbishing and using obsolete test equipment. Not terribly obsolete, it's all solid state, but it's still test equipment that isn't used anymore in the industry. I don't own any military surplus radio gear any longer. The last piece of equipment I had was an ME61 field strength meter, which was used in conjunction with various U.S. Signal Corps HF sets. But somebody made me an offer I couldn't refuse for it, so I let it go. I mean, he offered me an awful lot of money for the thing. It was brand new, so I couldn't resist selling it to him at the price he offered me.
Now, I noticed from your website and some articles that you've published that you ended up traveling around the world for your career as a telecom engineer. Where did you go from South Africa? Okay, well, again, that in itself is a bit of an interesting story. The original plan was to go to transfer to the Racal parent company in Bracknell, Berkshire, near Windsor. I would have loved to do that because I love that part of England. And I was all set to go there. I mean, we had everything set up for the transfer. But at the same time, again, my parents intervened in the sense that my mother drew my attention to an advertisement in the local paper soliciting applications for a competitive interview for a 3-year appointment at CERN as an RF engineer. And she said, "Why don't you apply for this? You've got nothing to lose. If you get it, it'll be absolutely marvelous. And if you don't get it, well, you still go to Racal and that'll be fine." So, fine. I wrote off to them. By then I'd sold off all my ham equipment and a little bit of test equipment I had accumulated. By the way, the highlight of my amateur homebrew career was the design and construction of a 20-meter SSB transceiver, which was hybrid, part tube and part solid state. It's fully documented on my website, including schematics. Okay, I'll put a note in the show notes page for that.
Yeah, okay, yes. That's definitely something that the person listening to the podcast should look up on the web.
And now this commercial message. ICOM America became a sponsor of the QSO Today podcast 5 years ago in March 2018. I want to thank Ray Novak, N9JA, representing ICOM, for being such a great sponsor for all of these years. It made a big difference and allowed us to grow the podcast and allow me to get some help from Ben Bresky for editing every week. I can't thank ICOM enough. It is time now for us to part our ways, both feeling that we had a nice run, and all things must come to an end. Being completely transparent, the QSO Today enterprise is a business under the KEG Media Inc. Corporation that I created to track and manage the business of the podcast and the expo. It has been through ICOM sponsorship that I've been able to make a weekly interview podcast, each episode taking about 10 hours of time from end to end to produce. It is because of this revenue that my XYL, Mrs. Farson VA7OJ, does not send me out into the cold to find more networking support jobs. I now have a choice to find new sponsors for the podcast, to make commercial reads at one of the 3 time slots in the podcast, or to appeal to you, dear listeners, for you to support the podcast through your time and treasure. This means that the QSO Today podcast from this episode forward would be commercial-free, except for the sponsorship segment in the middle and the referral to Ham Radio Workbench in the last third of the episode. Historically, only 5% of the regular listeners support the QSO Today podcast or any podcast. This makes sense as most of us grew up watching commercial television and listening to broadcast radio. PBS had an annual or semi-annual fundraising drives, but there again the majority of the viewers did not contribute. Adam Curry, K5ACC, known as the Podfather, inventor of podcasting, calls the system of listener support value for value. You trade time or treasure with me for the value that you get from the podcast. You contribute only what you think the value is to you. The new donation page has a slider that you can move from $5 to $1,000. The smile on the face gets brighter as the amount increases. This seems like a normal human reaction to listener generosity and not a negative for the smaller amounts. Personally, I contribute to all of the podcasts that I listen to and value them at different levels. You can become a listener sponsor of the QSO Today podcast monthly or annually by clicking on the new banners on the show notes pages. Listener sponsors and donors are listed by their total amounts on the show notes pages. This list is automatically updated every time a sponsorship is updated or a donation is made. This also includes sponsoring transcripts. You can even support the podcast by using our Amazon link on the show notes page. Amazon is very generous with a commission just from your purchases using our link. With your authorization on the sponsorship or donorship form, I will mention your name, call sign, and the amount in the following episode. You will be listed on the show notes page for that episode and listed by the total amount donated also in the show notes. For many reasons, including editorial, including what I say or don't say in the podcast, is often regulated by the sensitivity towards sponsors. I never had an unkind thing to say about ICOM, and I frankly never will. But I also was careful not to spend too much time talking about anybody else's radios except QRP Labs. All of these support methods keep the podcast free and alive until I just can't do it anymore. Without your support, combined with my obligations, I have to find commercial sponsors or close the QSO Today project and get another job. If you think that QSO Today is worth supporting commercial-free, please show your support by choosing one of the support options on the show notes page. And now back to our QSO Today. You've taken a job at CERN?
Well, I did in the end. Well, the way it all worked out was I was actually in England. I was interviewing with the Racal parent company, and during my stay there, I got a telegram from CERN asking me to come in and participate in the competitive interview. So I couldn't resist that. Obviously, I flew to Geneva, and they put me up in a hotel downtown, and I went out to the CERN campus, and I saw I was one of 3 guys who were being interviewed. There were 2 other boys there who were microwave engineers. They come out of the radar industry. I was the only one who had HF experience, and they wanted somebody who was familiar with HF because their operations were all at 9.5 megahertz. So in the end, I was the one who was awarded the appointment, and I had to inform Racal that under the circumstances I couldn't come and work for them. They were quite disappointed, but I'm certainly glad I went to CERN. I couldn't possibly look back from that. During my stay at CERN, I designed and built a modulation and switch system for the RF chain of a particle accelerator. It's highly specialized. What it did was it took a signal at 9.5 megahertz and switched it off at the 0 crossing of the 20th of 30 cycles, suppressing 10 out of the 30 cycles. This is all to do with not diluting a beam of particles. Another thing it could do is fill in the 10 missing cycles with a modulated signal.
Could you explain what CERN is, what kind of campus it is? And when we're talking a particle accelerator, we're talking about something absolutely enormous in size, aren't we?
Yes, well, CERN is it's a French acronym. It translates as the European Center for Nuclear Research. It's a multinational organization of which all European countries are members, both those in the EU and those outside the EU. At that time, Britain wasn't in the EU, and all the countries that are now in the EU, plus Britain and Switzerland, were members, are members. And because of my British birth, I was eligible to work there. They are dedicated to the peaceful uses of nuclear energy. They don't do energy generation research. They are strictly particle physics researchers. The Large Hadron Collider is the current example of what they're doing. It's the sort of the pinnacle of their efforts. But when I was there, they didn't have that machine. They had their largest machine was a proton synchrotron, which is a proton accelerator consisting of a ring 200 meters in diameter. And they were building a new machine called intersecting proton storage rings, which was a pair of rings 300 meters in diameter with 8 intersection zones where the rings would actually cross. The rings were made out of stainless steel tubing, and the intersections were X-shaped connector pipes, if you like. They looked like pipe fittings in the form of an X. And at each intersection, the beams, which were contra-rotating, collided with each other. The idea was to produce much higher collision energies than what could be obtained by crashing a beam into a fixed target. Now, when I said 20 and 30, the 9.5 megahertz RF signal caused the particles in the 200-meter ring to bunch into 20 bunches of particles, each corresponding to a cycle of the RF. However, the storage rings were 300 meters in diameter, meaning that they would need 30 cycles to fill them, but there were only 20 cycles. So what they had to do to prevent beam dilution was shut off the RF for precisely 10 of the 30 cycles, and that's where my device came in.
CERN has a much larger accelerator. How big is that accelerator, do you know?
The LHC, the Large Hadron Collider, is, I think it's 3 or 5 kilometers in diameter.
In diameter?
Yes.
Wow.
Oh, I'm talking about the diameter.
Right, the diameter of the accelerator. But it's essentially one continuous tunnel in a circle, right? And it's miles around.
Yes, well, if the diameter is 5 kilometers, so the length of it would be about 16 kilometers.
And it crosses the French-Swiss border.
It crosses the French-Swiss border, and it gets electrical power both from France and from Switzerland. In fact, its power demands are far greater than what the local Swiss electrical utility can supply, so they buy most of their power from Électricité de France, EDF. But the French have no shortage of power because they're 90% nuclear.
Now, you wrote an article that kind of was reminiscing, and I'll ask the question in that article a little bit later, but somehow you were talking about the Bell Labs. After CERN, did you work for any telecommunications companies?
Yes, in fact, I did. When my time at CERN was ended, by the way, through CERN, I was able to earn a master's degree from the University of Cape Town, where I got my original BSEE. When my time at CERN was finishing up, I took a vacation in Israel with my mother, and my mother was Israeli, by the way, and I took a vacation with her in Israel, and various people suggested to me that I think about working there. So I thought, okay, I'll look into this. I went to see a couple of local companies, including Motorola of Israel, but then GTE was setting up shop in Israel to build a satellite Earth station. It's the Emek Hayala Earth Station.
Right near my house.
Oh, very interesting. So, yeah, I worked there. I was on that site for nearly 3 years, back from 1970 until just the end of 1972. And they were looking for engineers, so I applied, and they made me quite a nice offer, so I accepted it, and so I lived in Israel for nearly 3 years with GTE, and that meant that I went straight back into the telecom industry. I was working on satellite communications, which was really a sort of a crossover between RF, pure RF technology and telecommunications in the sense of providing a public communication service. So I began to learn aspects of the telecom side of the business, transmission, switching, testing of transmission systems, and all those related types of disciplines. Now, at that time, I was not an active ham because my South African license expired or lapsed when I left South Africa. Unfortunately, the arrangement I'd made to get the fee paid annually failed. The bank dropped the ball one year, so the fee didn't get paid and the license was cancelled. I didn't get back into amateur radio until 1976 when I found myself in Toronto. So I stayed with GTE in Israel until the end of 1972 and decided I really wanted to move to the States. I tried to get a transfer with GTE to their head office in the Boston area, but there was a big problem. Because of the wind down of the Vietnam War, there were 28,000 unemployed engineers in the Boston area alone, and they weren't about to give a visa to a foreign engineer under those conditions. So that didn't work out. But I managed to get a contract job with a subcontractor to GTE under a temporary visa in the Washington, D.C. area. And that was fun. I was doing a different type of work then. I was working on small switching systems rather than transmission. And that lasted until the company got into financial trouble, at which point, again, I started looking around, and Nortel in Toronto were recruiting engineers, so I went and joined them and stayed with them for 5 years and gained more experience in the telephone switching area. Hence, that there's a tie-in there to the Bell Labs article. And then after that, I wanted to change again. I was still young enough to think about moving around a bit. I went to work for GTE in Chicago, also on public telephone exchange switching. And then, by the way, I was licensed again. I got a Canadian license in 1976 with a call sign VE3 Delta Golf Yankee, which I subsequently changed to VA4OJ when the 2x2 program came out. So I stayed with GTE in Chicago until they started getting into financial trouble. This seemed to follow me wherever I went. And at that time, I was at an age where I thought I'd better settle down and think about getting a retirement. So Siemens was looking for engineers, and they cleaned a lot of people out of GTE, including me. So I went to work for Siemens in Florida, and that was I stayed with them for 20 years. I had a wonderful time with them because, again, I was able to work internationally. They sent me to Japan for almost a year and to Germany for a year. I spent a year with them in Munich, and I finally retired at the end of 1999. And having picked up a lot of knowledge, which I still use today in testing radios, because the work I was doing at Siemens was test and verification of switching and transmission equipment.
In 2002, you wrote an article called Reflections of a Retired Telecom Engineer. What struck me about the article was, growing up in Southern California and the United States, I kind of thought we were like on top of the world in terms of telecom infrastructure, telecom technology. We had touch-tone phones and we could dial anywhere. It was expensive. But what struck me about your article that you wrote in 2002 was that, in fact, while the Bell Labs was a leader in creating things like the transistor, the accomplishments of the European telcos and their vendors seemed to dwarf the American accomplishments by comparison. Is that what you intended in the article, and did I misread this, or is this actually what happened?
You were correct in your assessment, but I think I can explain it by saying that the Europeans were driven by a different set of imperatives. The Bell Labs, the Bell system was, I don't mean to be critical of them, but they were sort of obsessed with a type of service to the customer based on the concept that of the so-called personal touch. They'd grown up, the Bell system had grown up with operator-assisted telephone service, and to them, this was a concept akin to flying first class. that expecting the telephone user to dial his own calls was making him work too hard, that he felt that he was being coddled in the lap of luxury if he could get his call completed by an operator. Of course, it suited the telephone company because they made a lot more money from operator-assisted calls. What was a rude awakening to the Bell system was the 1947 strike, in which operators as well as craftspeople, in other words, maintenance technicians and so forth, were caught up. And this forced them to accelerate the pace of conversion to automatic switching and even more automated maintenance. The Europeans had the union problem before World War II. So an example is that in Germany, the state of Bavaria installed a regional direct dialing system in 1935, where you could dial all over the state of Bavaria just by dialing a code followed by the number. Another thing that the Europeans perfected was automatic billing, which was easy for them because local calls were metered, whereas in North America, local calls are generally flat rate. That meant that each subscriber in Europe had a meter associated with his line in the exchange. The meter was a little counter, a little electromechanical counter, and every time he made a local call, the counter would advance one count. At the end of the month, photographs would be taken of the meter racks and run through a scanner, and in this way the monthly call charges would be determined.
This is where the term message unit comes from, I think, right?
Yes, the message unit was one metered call unit. In Europe they called it a metered call unit or a metered unit. In German it's called by a word that means metering pulse, and or meter unit. So they said, okay, we've got these meters in place for local calls. If we want to offer direct dialed long-distance service, we simply generate one pulse every so many seconds, with the interval being the inverse of the distance between the calling and called parties. And we'll operate the subscriber's meter in that way, and in this fashion we have billing without any extra cost to ourselves. The disadvantage is that the user doesn't get a detailed bill. The advantage is that it's awfully cheap to implement and requires very little additional equipment. All that was needed was a pulse generator in the toll transit exchange, which would generate pulses at the proper rate for the distance between the calling and called parties, which could easily be assessed by translating the dial digits. When international direct dialing came along, the Europeans used the same scheme, excepting the meter would be operated rather rapidly if you made a call from, say, Frankfurt to New York. It would be one pulse every 10 seconds or so, but still the public didn't mind because the rates were reasonable, and the big advantage was you didn't have to pay for a 3-minute call. If you made a quick call to say that you would be arriving at Frankfurt Airport at such a time, and the call lasted 15 seconds, you'd be charged for 15 seconds. Another thing that I mentioned in my article was that the British Post Office, working together with local governments, instituted 999 emergency calling in the UK in 1932. And because this was in place during World War II, it saved probably hundreds of thousands of lives.
This is compared to 911 service, which I think started in America in the 70s, after the Carter Phone Act, right?
Right, the Carter Phone Act pushed 911 service. There was a lot of pushback against it. Now, the thing was, with the British Post Office, there couldn't be any pushback because it was His Majesty's government. I mean, there was a story where, and this is why I didn't document this in my article, in the early days of public telephone service in Britain, there were competing telephone companies that didn't interconnect. If you wanted to call across London, you needed 3 phones on your desk, and it was ridiculous. So, well, the Post Office went to court, and then they got a decision from the High Court that a telephone call was a telegram of sorts, and as a telegram, it would fall under the purview of the Posts and Telegraphs Act, granting the Crown the monopoly of telegraphy. Therefore, the Crown had a natural monopoly of the telephone service. This enabled the Post Office to go out and nationalize all the telephone companies in one fell swoop by Act of Parliament. And that was the end of that story. So the Europeans had freedom of action that would have been impossible in the United States because of all the, let's say, contrary parties involved, the special interest groups would have fought like tigers to stop such a measure from being implemented.
Let's change gears. I was looking at your website, and I noticed that you're a big advocate of ICOM radios. So I was kind of interested in your list of, you once had a classic ICOM station. What is a classic ICOM station? How would you define a classic ICOM station?
The real top-of-the-line classic ICOM station would be an IC781 transceiver with an IC2KL amplifier and the AT500 auto-tuner. In fact, I had that lineup at one time. The IC781 was, I used to call it the king of beasts. It was the first, well, it wasn't the first, it was the second of the, no, I think it was the first of the big box ICOM transceivers. It had a built-in mains power supply. It was 150 watts. It was ICOM's first radio to have a built-in spectrum scope. This was a long-time dream of mine, a radio with a spectrum scope. In the satellite Earth station, we had a spectrum analyzer up in the antenna hut with a monitor down at the control console. It was remoted off the analyzer so we could keep an eye on the occupancy of the satellite transponders. And I remember saying to a colleague who was a ham, said, one day we will have an HF transceiver that will have a built-in spectrum analyzer which will enable you to monitor the band. He said, never. I said, well, just keep your eyes open. Well, it happened with the IC781. And I did own one for 5 years. I absolutely treasured it. And since then, every HF radio I've owned has had a spectrum scope. It's like flying blind if you don't have one.
I want to take a minute to tell you about my favorite podcast, the Ham Radio Workbench Podcast, with George, KJ6VU, and now joined by Rod, VA3ON, Mike, VA3MW, Mark, N6MTS, and Vince, VE6LK. Every 2 weeks, George and company offer up a status report on the many amateur radio projects on their workbenches and explore projects on their guests' workbenches. This group is project active and prolific, covering many technical areas of amateur radio. So the next time you want a deep dive into ham radio electronic project building, or to learn about technology, tools, test equipment, construction techniques, and the rest, listen to the Ham Radio Workbench podcast, available on every podcast player and channel. Use the link in this week's show notes page to get to the Ham Radio Workbench podcast directly. And now back to my QSO. Now, you have an ICOM oldies but goodies list. Could you describe a little bit about what are oldies and goodies in the ICOM line?
Oh, sure. Well, the 781, the IC751A, IC751, IC745, IC735, which was a real little classic in its own day. It was a compact, fully featured HF transceiver, which was extremely reliable. The hallmark of the 735 was that it never broke unless it was grievously abused, and even then it would take a lot of punishment. There are others, such as the IC740, the IC730, which was ICOM's first compact transceiver.
Did ICOM ever have a radio like the Yaesu FT817, like a field radio?
Yes, the IC703, which personally I think is a better design. The 703 is in the same form factor and cabinetry style as a 706, but it's a fully featured HF transceiver, 5 or 10 watts output depending on the battery voltage, and it has a built-in relay chain type auto tuner with latching relays. So when the tuner is matched, it doesn't draw any power.
Yeah, similar to some of the other portable radios we see now in the field. Do you think that, I noticed a YouTube where you're demonstrating the IC7300. It looks like in ICOM's booth at a trade show.
Yes, it was an ICOM booth at Dayton.
Oh, at Dayton, okay.
Yeah.
So it must have been 2 years ago.
Right, yes. I've been going to Dayton pretty well every year since I retired, with the exception of a few years during my mother's final illness.
Does ICOM have any plans for a new portable radio for people that want to do QRP in the field?
I haven't heard anything along those lines. I think right now, with the condition of the bands, there doesn't seem to be an awfully strong incentive on the part of the manufacturers to build out to bring out a high-end QRP transceiver. Given
the high-end QRP transceivers that are already perhaps in the marketplace.
Yes, I mean, the only one that's surviving now is the FT817.
And the Elecraft KX3, KX2s?
Oh, yeah, I'd forgotten about the K. Yeah, of course, there's the KX3 and KX2.
You mentioned earlier that one of the things that you do on your benches is that you restore solid-state test equipment. What kind of test equipment are you restoring, and are you using that same test equipment to do the surveys and user reviews and test reports that you have been doing for ICOM, Yaesu, and a large number of SDR products?
Yes, in fact, I've introduced some new test methods for HF transceivers. One of the new forms of testing that I've brought in is not a new form of testing in an absolute sense. I've taken noise power ratio testing, which is the use of a band of noise with a deep notch in it. This was a test which was used for the testing and qualification of analog frequency division multiplex carrier systems used in the telecom industry. I've taken this test method and applied it to the testing of HF receivers. And this requires using the same test equipment as was used in the telecom industry during the era of analog transmission. The equipment itself doesn't have to be modified, but the way in which it's used has to be changed somewhat. What I do is I apply a band of noise to the receiver, and the bandwidth of this noise band is limited by bandpass filters in the noise generator. And also in the signal path is a very deep notch filter, typically 90 to 95 dB deep, and the bottom of the notch is about 3 kilohertz wide. And I put the receiver in SSB mode and tune it to the middle of the notch. The less noise is induced in the notch, the better the receiver. What happens is that the noise loading, as it's called, which is very high, it's actually a very aggressive test. The noise loading causes impairments in the receiver, such as reciprocal mixing, in other words, the effect of phase noise, IMD, and noise floor degradation in the receiver. And all these effects show up as noise in the notch. The objective is to keep the test noise band out of the notch, therefore out of the IF. So any noise that shows up in the IF is generated within the receiver. And I use this test as a very powerful test tool for assessing the strong signal performance of the receiver. And it's slowly starting to catch on. I think the reason why this test has not grown as fast as I'd like to see it grow in the world of receiver testing is the availability of the test equipment. I'm using the noise power ratio test equipment, which was used for many years in the telecom industry, which has now gone into the surplus market because all telecom transmission systems are now digital and different forms of testing are used.
So what would be an example of this equipment? Was it made by Hewlett-Packard, or was it made by people who tended to be more towards the telecom industry?
Well, there were four manufacturers that I can think of off the top of my head. Marconi Instruments, which at one time made a general line of test equipment. Wandel and Gortermann, a German company which built test equipment, specialized test equipment for the telecom industry. They are no longer around, unfortunately. They built equipment of the same quality as Rohde and Schwarz. Hewlett-Packard made an NPR test set at one time, and so did Scientific Atlanta. And I think Siemens did as well. I'm pretty sure Siemens also built an NPR or noise power ratio test set because I've seen a couple of the filters from one of their test sets. So what I do with this equipment is it shows up on eBay. There are two pieces of equipment. One is the noise generator, and the other is a specialized receiver, which has channel filters in it on the same frequency as the frequencies as the notch filters in the generator. The notch filters are on the frequencies of standard carrier channels used in the system, in the telecom system. So what you have to do is you have to accommodate the frequencies on which you propose to test a receiver to the available filters. Some of the filters fall right into amateur bands, for example, on 160 and 80 meters and 60 meters. For 40 meters, the closest filter you get is 7600 kilohertz. For 30 meters, there's a filter on 11.7 megahertz. And for 20 meters, there's a filter on 16.4 megahertz. The alternative is to build your own filters. A friend of mine is also doing NPR testing, is building his own filters. But if you want to use the surplus filters, you're stuck with the frequencies you get. However, that's what I do. I don't try to build filters because I don't have good facilities here for building on any scale. So I just test on whatever frequencies are available. I do have the full set of filters because I've kept my eyes open on eBay. But when I get this equipment, it's in varying states of repair or disrepair, so I have to fix it sometimes. And I have a full set of service manuals which enable me to go in and make repairs. The equipment is all discrete through-hole components, etc., and uses common parts, so it's very easy to repair.
I mentioned earlier that you have this list of user reviews and test reports for the ICOM, Yaesu radios, and a large number of SDR products. Does this list, would you say, compare to, say, Rob Sherwood NC0B's list of radios, and do you have top choices that have passed your tests?
That's an interesting one. It's a slightly difficult question to answer because Rob's approach to testing and mine differ somewhat. I work with Rob. He's a good friend of mine, and I work with him a lot. I also work quite a bit with the ARRL lab people. Rob tests the receiver. He doesn't often do transmitter testing. I do a much more exhaustive test. I spend a lot more time on a given radio than Rob does. And it can take me up to 3 weeks to test a radio and write up a test report. I test the receiver and the transmitter. And I do a lot of tests on the receiver, all the classic tests, plus noise power ratio. And in testing SDRs, I don't do the classic third-order dynamic range test because the third-order dynamic range of an analog to digital converter cannot be defined in the same way as that of a conventional receiver or legacy receiver. What I do is I measure the absolute power of the IMD products over a range of input levels from 1 dB below clipping to the noise floor and draw a curve. And I call that interference-free signal strength, or IFSS. The idea is that if the curve is below the ITU band noise line for the site at which the radio is to be used, then you don't worry about it because you won't be able to hear the IMD product. You can't hear anything below the band noise. For SDRs, I always draw up an IFSS chart, and it goes into my test report. So I don't rank receivers in quite the same way that Rob does. For example, because I don't do a third-order dynamic range on all receivers, I don't use that as a ranking criterion. The only ranking I do is by noise power ratio. But you can have a receiver which will have moderate third-order dynamic range and excellent noise power ratio. It all depends on the construction of the front end. The thing about third-order dynamic range in a conventional receiver is you have to test reciprocal mixing dynamic range, which is a measure of phase noise at the same time. Because you can have a radio with 100 dB dynamic range and 80 dB reciprocal mixing, and it's not a 100 dB radio anymore, it's an 80 dB radio. But at the same time, because reciprocal mixing is not the whole story but only part of the story, if the radio has a really good front end, it can have very high noise power ratio figures. An example is the IC7700 from ICOM. Its reciprocal mixing is around 80, which is average, because it has a conventional synthesizer. But its noise power ratio is above 85 dB, which is, on the scale that I've established, sensational. Noise power ratio, the number ranges from 40, which is dreadful, 50, which is unacceptable, 60, which is marginally acceptable, 70 is good, 75 to 80 is very good. I'd say 80 and above is excellent. 85 is really top of the line, and that's where you'll find things like the IC7851. The reason why I got so involved with ICOM equipment is it's sort of complex. My first ICOM radio was a little IC4AT handheld, which I purchased in 1984, and I noticed that it didn't have the intermod problems, which so often plague amateur VHF and UHF equipment, FM equipment. So I thought, they've done a lot of good engineering in this little radio. Then I started working with ICOM equipment owners, and I joined the ICOM HF Users Net. There was a group of ICOM owners who ran a net on 14.317 kilohertz, and I became a net control operator on this net in 1989 when I was living in Florida. And I've worked with those guys. I was a net control right up until I retired in 1999. And then the people on the net all went their separate ways, unfortunately. But during the time when we had this net, it was like an on-air service and repair clinic. I recall we used to have, several of us had libraries of service manuals, and a question would arise about a fault or a problem in a particular radio, and we'd actually walk the owner through the service manual over the air and suggest to him how he could go about fixing the problem. And we had a lot of fun doing this, and it was actually a very constructive activity. And I realized from all of this that ICOM is a very engineering-driven company, and that's what I admire about them.
If you're a new ham, or maybe you're a ham that's been off the HF bands for a while, what would be a great starter rig from the ICOM line?
Oh, I'd say the best starter rig of all, without hesitation, would be the IC7300.
Because?
Well, first of all, it's in keeping with ICOM's tradition of always being at the leading edge, which they have been as long as I've known them. It's an SDR. It's a direct sampling SDR. So it's unlike any of its competition in its price class.
Right, so it competes easily with Flex Radio, for example.
Well, it's less expensive than Flex Radio, for one thing. It's only, in the States, you can get an IC7300 for around $1,100 now, I think.
Which is pretty amazing.
The dealers are offering them at about, the standard dealer price is around $1,250, and many times they offer a $100 discount coupon. So you can get a radio, you can get a really first-class radio for just over $1,000.
Now, there's a number of radios, transceivers, that come out of the Tapper group. One of them is the HSPDR.
HPSDR.
Can you talk a little bit about those? Because you appear to be reviewing those radios. How did you get involved with Tapper?
I became friendly with some of the principal players in the Tapper development organization, such as Warren Pratt, NR0V, and Ken Hopper, N9 Victor is also a good friend of mine, and he was involved with them for some time. I think he still is to some extent. And through them I learned that a firm in India, Apache Labs, had brought out a commercially manufactured version of part of the Open HPSDR line under the ANAN name. So now you have various ANAN radios. There's the ANAN 10, which is a small one, low power. Then there was the ANAN 100/200 series, which was a 100-watt class radio. And the current models are the, excuse me a second, the ANAN 8000 DLE, which is a 200-watt radio. It's a big, fairly expensive radio. And the ANAN 7000 DLE, which is a 100-watt, more compact radio. I've just finished testing it, in fact. I've still got the radio at the house here. There's one more test that I'm planning to do as soon as I finish building a test fixture. And this is a nice medium-priced compact radio, and its performance is very good, judging by the tests I did.
The tests that you've made, how do they compare? One doesn't think of the Tapper gear. I think of them more as kits than commercialized radios. But it sounds to me like Apache Labs has changed that paradigm for the HPSDR radios. Yes,
they have. They've taken basically the same designs as used in the kit, and they've made them into a commercially manufactured, ready-to-use package.
How do they compare?
Oh, I think you eliminate the uncertainties due to home construction of the radio, of course. The packaging is very good. They've managed to get an awful lot into a fairly compact package. I had noticed, and it's documented in my test report, there are some minor spurs, probably due to proximity of some components inside the enclosure. I've addressed a couple of these, and I'm hoping that they'll make some changes and get rid of them.
But unlike the ICOM products, these radios don't have controls on the front panel, right? They're actually PC controlled.
The PC controls, although there are several of the designers have come up with a Raspberry Pi-based control head, which can be used in conjunction with these radios. There are several variants of this control head.
So us old-time ham radio operators get our knobs back.
Yeah. Well, my personal preference is for a radio with knobs. Actually, as the way I phrase it, I don't like mousing a radio. I read on the amateur radio forums, the I/O groups and so forth. I read about these constant struggles that these poor guys are having with all the software that they're using. I'm wondering if I'm dealing with a ham radio group or a dysfunctional IT organization.
Yeah, sometimes it's hard to tell. What project's on your workbench right now?
Well, right now, the only project left on my workbench is a 12 megahertz precision test fixture consisting of a high-quality crystal oscillator, a power supply, and an EMC filter. I'm waiting for a chassis which I'm having made up. The idea there is to build a test fixture which I can use for phase noise measurements at 12 megahertz rather, excuse me. And I already have one for 5 megahertz. I do the reciprocal mixing testing at 5 megahertz, but I'd like to do it at 12 megahertz as well. So I got a second oscillator. And I've built another test fixture for third-order IMD testing, which has a couple of wideband amplifiers on it, a combiner, some attenuators and filters, an EMC filter, and a mains power supply.
What excites you the most about what's happening in amateur radio now?
Oh, I think the thing that I find most exciting of all is the rapid evolution of technology, the startlingly fast adoption of SDR, which seems to be sweeping everything in its wake. So much so that I would say that those OEMs that don't get on board with SDR may not be around in the next few years.
So you were talking about that you're excited by the rapid evolution of technology, and especially SDR technology. Is there a digital mode or something that excites you now?
I'm sort of rather conservative in that sense. The only modes that I use with any regularity on HF are mostly SSB voice and a little bit of CW. I've not really taken to the digital modes, probably because I was exposed to them too much in my professional career.
Do you operate DMR, or I noticed that you had on your website that you actually used to build and maintain the MyCore repeaters?
That was all FM.
In the olden days?
Yeah, I've not got into DMR. There is a DMR repeater in our area here, but I don't have a DMR radio. Well, the Motorola radios are very expensive, and I'm a little hesitant to buy any of the other brands. I have a D-Star, UHF D-Star handheld, but unfortunately there's no UHF D-Star repeater within range of my house.
What advice would you give to new or returning hams to the hobby?
Well, I'd say take a look around and make a decision as to what aspect of the hobby you want to get back into. Do you want to be a VHF, UHF operator? Do you just want to hang out on the local repeaters, or do you want to get into HF? HF is getting more and more difficult now with all the restricted housing arrangements that are springing up everywhere. Fortunately, we don't have this problem in Canada yet to any major extent.
Canada doesn't have codes, covenants, and regulations in housing developments?
Very, very little of that, because under the Radio Communications Act, Industry Canada, which is the regulator, technically has sole jurisdiction over licensed transmitting sites. Hams enjoy a de facto authorization to put up an antenna structure at their place of residence as long as the height doesn't exceed 15 meters.
It doesn't exceed 15 meters, which makes it about, 48 feet, 45 feet?
50 feet. We don't do the King's Foot around here. It's 15 meters is 50 feet.
So you can have a tower and a beam and all that stuff in your neighborhood with no issues?
In most areas, yes. Some places are a little difficult. The city of Vancouver puts up obstacles, but they'll back down if they find that they have to get into a confrontation with the federal government. Even
here, I think we've all taken it in the chin because of the cell phone regulations. People don't like having cell phone towers in their neighborhoods, and so therefore they think anything that looks like an antenna might be a cell phone antenna, and so therefore the hams get painted with the same brush as the cell phone operators.
The unfortunate thing about it is that the people who don't want cell phone towers demand better cell phone service.
They do, yeah, and they go to bed with their cell phones under their pillows, but they're worried about Wi-Fi radiation from their access point.
Well, somebody needs to take a strong stand on this and, get on the media and start educating people.
I agree with you 100%. You've been such a great guest. I know there's a lot more we could talk about, and I hope that people will engage with you on the QSO Today website comment section. I want to thank you for coming on board the QSO Today podcast and spending an hour with me.
Oh, my pleasure.
Great. 73.
73. Thank you for calling, Eric. Bye-bye.
That concludes this episode of QSO Today. I hope that you enjoyed this QSO with Adam. Please be sure to check out the show notes that include links and information about the topics that we discussed. Go to www.qsotoday.com and put in VA7OJ/AB4OJ in the search box at the top of the page. You may notice that some episodes are transcribed into written text. If you'd like to sponsor this or any of the episodes into written text, please click on the Sponsor Transcript button below the guest picture on the show notes page. Support the QSO Today podcast by first joining the QSO Today email list by pressing the subscribe buttons on the show notes page. I will not spam you or share your email address with anyone. Become a listener sponsor monthly or annually by clicking on the sponsor buttons on the show notes pages. Use our Amazon link when you shop on Amazon. Click on this link before you enter Amazon, and Amazon will pay us a small commission on what you purchase. This is a very painless way to support the QSO Today podcast without paying us anything directly. QSO Today is syndicated on every podcast platform, including Spotify and the iTunes Store. Please leave us a review on the iTunes Store, as this helps to get the word out about the QSO Today podcast. Until next time, this is Eric, FARson 73. The QSO Today podcast is a product of KEG Media Inc., who is solely responsible for its content.